Sotero. I am a singer, eternal voice. So our topic for today is decomposition chemical reaction. Wow. Decomposition, John. Let's take two example. A very basic example only. The raw material of cement production and also the raw material of a chalk. CHALK that we use to write in our board. So chalk is made up of calcium carbonate. And calcium carbonate also is limestone, raw material of cement production. So let's say example for calcium carbonate decomposition, right? Okay, so what is the requirement for decomposition? So it could be natural or artificial. What do you think in your brain cells when you mean a decomposition? Do we have to apply external energy or just let it be and it will decompose immediately? So what comes on your mind? Okay? You get the point? Okay. Do we have to apply something to decompose or nothing at all? Okay? So actually the answer will be both. Sometimes have decomposition directly in a nature. Okay, for example, ammonia by nature, the fertilizer, something like that.
The Bluetooth device is ready to pair.
Okay, ammonia. Okay, for example, I just touch ammonia because this is natural. Okay, you don't have to apply external energy, or you don't have to apply burning process. You don't have to apply temperature, higher temperature or heat just to decompose ammonia because it is really a natural process in the atmosphere. Okay, like that. So ammonia, for example, NH3. Oh, ganun. So it will decompose to nitrogen gas plus hydrogen gas. So this is also an example of a decomposition chemical reaction, but this is mainly gases decomposition. But calcium carbonate is a solid decomposition. So example number 1. Okay, so ammonia and 2H2. So again and again and again, we need to balance the chemical reaction before going further. Okay, so N2 nitrogen ganun siya. Okay, so X is equals to 2. Okay, equilibrium. Okay, and then H6 or 3. So 2X is equals to ganun plus 3. Okay? I don't have to show the algebraic expression of how to balance because I discussed it already in my last vlog on how to make the balancing of chemical reaction through the use of algebraic balancing, not the trial and error method. I don't have to explain over and over again, right? It's very easy to detect and to understand that. Okay? So we have 2 nitrogen, 6 ammonia, balance the chemical reaction. So 2 moles of ammonia will produce 1 mole of nitrogen gas plus 3 moles of hydrogen gas. This is known as the Haber process. Okay, Haber process. Okay, so this will come out also in the board examination or any examination in the future. It will just be like this. Blanc is a process that will decompose ammonia to nitrogen and hydrogen gas. A, blah, blah, blah. B, blah, blah, blah. C, blah, blah, blah. D, blah, blah, blah. E, none of the above. So, just select Haber process for this. Okay? Because we have also Leblanc process. I think Leblanc process, it's all about, oh my gosh, my brain cells will not flashback anymore. Leblanc, I think it's gonna be sodium chloride. Leblanc process. Never mind, just double check guys. Murali santop sa akong brain cells. Leblanc process is another process also. Okay? But sure, Haber process really is ammonia, decomposition of ammonia. Okay? So going back to calcium carbonate. Okay? So calcium carbonate. Okay. So calcium carbonate. Okay. So we need to apply delta, meaning to say heat or temperature. Okay? In order to break this solid. Okay? Like that. Why? Because there's the presence of carbon dioxide here. See? Get the point. So after applying it, or let's say burning or whatever, applying temperature, and then the calcium will exist as a solid, and the carbon dioxide will release to the atmosphere. Okay, like that. So that is calcium plus, okay, CO2. Ganon. Okay, calcium carbonate. Okay. Plus CO2. You have also to be clever enough, guys, that, okay, in this case, there's a lot of option. Because actually, guys, I don't memorize. When I was in college, I don't memorize really the perfect products to be produced. Okay? I'll just analyze, it's gonna be like this, at a certain condition. Okay, that's why we have option 2 by 2. Because in here, guys, we can say also calcium plus carbon dioxide. And we can also sometimes say calcium oxide plus CO2. Okay, now you try first one, because I said earlier, I don't memorize, I don't prepare. Okay, so if I prepare, I study, then I get correctly, exactly the decomposition. But this is on the spot, that's why. Okay, so it's either two option. We need the calcium plus carbon dioxide, or calcium oxide plus carbon dioxide. Okay, now, how can we identify which is correct? It will be balanced. If it will not be balanced, that is incorrect. Okay? Because, I found it awkward sa calcium, then because there's a lot of oxygen. There are 3 atoms of oxygen in calcium carbonate, right? And then if I will say CO2 only, there's a deficient of 1 oxygen. Okay? If I will really force to have that product, calcium plus carbon dioxide. Then in the second option, I have calcium oxide plus calcium carbonate. Then I can say that the oxygen will be balanced immediately through visual inspection, because I have 3 atoms of oxygen in the reactant, in the limestone calcium carbonate, and the product also I have 3, and I have 1 calcium and I have 1 carbon also. Then perfect, it's already balanced. So we can say automatically without question that our option 2 is the correct products of the decomposition of calcium carbonate by applying heat at a certain temperature. Okay, ganon. Perfect balancing, okay, without putting any coefficient at all. So this will become, okay, calcium oxide, okay, calcium oxide plus CO2. Perfect. I will explain further. Carbonate have -2 charge and calcium plus 2. So neutralization reaction, it will become 0, right? So it will become a compound. Okay? So cancels. Now here, calcium oxide, the charge of oxygen is -2 and the charge of calcium is +2. So -2, +2 cancel. Okay? I'm talking for the oxidation number and the oxidation state. Okay? Now for oxygen, -2 and +2 also, right? Like that. Then, bingo, it will be 0 also. Kalas. So this is perfect balance already. Without putting, diba? Perfect. Without putting any coefficient or numerical figure, diba? Kasi special. Now, before I end, I will add also another example. Actually, there are billions examples of decomposition chemical reactions. Billions, trillions, and we cannot discuss everything. Okay? Like that. So another example, we have, say, hydrogen carbonate. Hydrogen carbonate, wait na siya, guys. Or carbonic acid. Right? Okay, let's explain why. So H2CO3. Some will call this as carbonic acid, and some will call this as hydrogen carbonate. But it's just the same. Okay? Why I never say dihydrogen carbonate? Because this 2 is coming from the charge of carbonate. And hydrogen there is only 1, not 2. And hydrogen will never exist as diatomic sa compound. Okay? You get the point? It will just exist as a diatomic when it become a solo flight alone. Solo flight meaning as H2. Okay? So it's not also H lang siya. Unless you have the ionic balancing equation. For example, HCl. So H plus chlorine negative. So that will exist as H. Press a negative off, guys, HCl. Okay, it will exist as H plus chlorine. Chlorine negative, H positive. But this is ionic equation. In a chemical reaction, you will never say hydrogen. It's always diatomic in the product. Diatomic hydrogen, meaning H2. Okay? It will never exist as H. Muna yung timanan ko rin, guys, ha? Okay. Like that. Okay? So, marong jud mo if you put H only. It's always H2 build, unless ionic chupa-chucho. Okay? So, here, this is hydrogen carbonate, not dihydrogen. Because you will see the 2 here, you will say dihydrogen. No, it's not. Because the 2 is coming from the carbonate. You get the point, guys? And hydrogen, positive 1 only proton. Okay? Atomic number, like that, blah, blah, blah. Proton, positive 1. Diba? The proton will represent the atomic number. If you can remember that one, right? That's why we have isotopes. Isotopes are those elements that have the same atomic number or the same number of protons but differ or different mass number. Okay, isotopes. For example, carbon 12, carbon 13, carbon 14. O, diba? Different mass number siya. But ang proton o ang atomic number pareho rin siya. Okay? Ana lang. Okay? So H2CO3, what is the product for this? Applying heat. Heat, guys, we will just put delta. Okay, delta in chemistry. Triangle, small triangle. Or we can put also word HEAT. But normally, we don't put heat anymore. It's understood if there's a small triangle. You get the point? Okay, so delta. Understood na siya heat, nasa siya temperature. Okay? But, nunit sa talaga siya in other books. Wala na siya ibutang. Araw na siya dito. Okay? Because this we mean of decomposition. So it will become H2O and CO2. So iba rin talaga guys na ang carbonate GDI mo release siyang carbon dioxide yun. Okay? So muna mong timanan Bernie, ang carbonate mo release yung carbon dioxide. So that dili na ka maglibog in different chemical reactions that involve carbonate chuba-chucho. Get the point? Okay. So, carbonate, CO2 plus H2O. As you can notice also, this is also like a combustion. But, we will never add oxygen in the rapid oxidation. Here. You'll never add oxygen. Because this is a decomposition reaction, not a combustion. But what I mean, the product is just the same. Carbon dioxide and water. Get the point? Okay, because of the presence of H2 here. So balance the chemical reaction. Last example, okay? Take a look. Oh my gosh. Okay guys, so here we need to balance by algebraic because you know, there's a lot of Sanskrit chuba-chucho. Okay? Sanskrit. Okay. Kasi natago guys. Kaloka. Okay, so carbon. Carbon. Almost, you know, all of the materials here on Earth are composed of carbon. When you burn that out, there will be a black particle. That's the presence of carbon. When you burn the sugar, the white sugar, there's also a black particle. So it's the presence of carbon. Anything that's a blackish color, that represents carbon. Even the paper, the chair, or if there's a fire, you can see, you know, a lot of black ashes or black residues. So those are the presence of carbon atoms. Get the point? Okay? Like that. Okay, so carbon, okay, 1. And carbon here is also 1, balance, right? Oxygen, 3. And oxygen also here is balance. Wow, perfect! Balance na relationship so guys, di ba dito tayo? Ang carbonic acid or hydrogen carbonate decomposition, it will be balanced immediately, just like the calcium carbonate. Okay, di ba? Huwag yun ako tuyua, guys. I never do it intentionally, but I use also the examples that are perfect. No need to put coefficient like that. See, by visual inspection alone, okay? Carbonic acid will produce water and carbon dioxide. Balance the chemical reaction. Carbon 1, carbon 1. Oxygen 3, oxygen 3. 2 hydrogen. Perfect! O, di ba? So, perfect ang carbonic acid ang calcium carbonate. You don't need to put number of moles. And you don't need to put coefficient or numerical figure beside the compounds. And I thank you. Thank you so much for this topic. And I hope you understand the decomposition reaction. And if you like to subscribe to my YK channel, then you can do it. And you can click the notification bell for some news updates of I'm a singer, eternal voice. Bye bye, God bless everybody. See you later.